Good afternoon, everyone. Do I click on the? Good afternoon, everyone. I'm Mohamed Numair from Glasgow Caledonian University. I'm a PhD student, and my project is between Scottish Power and the university, and we are trying to create a digital twin. That's why my presentation is on the UK smart metering system and the value of its data to distribution system operators and the entire network. Today I will talk briefly about the background motivation of the smart metering implementation program. Then I will show, discuss briefly how the architecture of this system is working, and then we can see the benefits it provides to the entire system, and with a focus on the technical benefits to the distribution system operators. Finally, before concluding, I will talk about some of the challenges that are constraining unlocking these benefits, and then I will sum up with a conclusion. So since 2008, with the UK passing the Energy Act, there has been a program called the Smart Metering Implementation Program that was planning to initially have 53 million smart meters connected to the network by 2020. And we can talk about Smart Energy Code or SMETS, SEC or SMETS. Smart Energy Code would be the regulatory outline for the system or for the program, and SMETS is the technical specifications for the smart meters that would be used in that program. And after that, of course, as we know, since the Paris Agreement having a global effort to reduce the climate change, and then that was even reinforced here in Glasgow to keep it below 1.5 Celsius. And the outcome here, I want to mention that there was the outcome creation of new partnership between government, private businesses, and civil society to accelerate the action to climate change. And we can see that actually in the number of installation of smart meters that has been connected to the network. Since 2021, there has been a rapid increase in the installation rate. But we can see that till the third quarter of 2022, we're still at 24 million smart meters connected, which is short of the 53 million that we had initially. So we can discuss why did that happen before. But before unlocking any benefits or talking about having any benefits of any system, we need to understand the system first. So starting from the consumer premises, which is the large part of the network or the large part of the system, we have in any consumer premises, as some of you must have in their homes, a smart or electricity or gas meter. The electricity meter would have what's called a communication hub above it, which connects to two types of networks: a home area network that connects to other devices, the gas meter, and an in-home device, in-home display device. And also there is another network, that cellular network, that connects to the main DCC or the network that gets all the smart meter readings into one place for the entire system. So before knowing what are the technical benefits, what are the technical values or measurements that I can get from each of these smart meters? So we found that I can get the half-hourly power consumption or generation for each premises. Also the maximum demand, the voltage measurements, and a number of useful alerts and alarms, such as power status and a lost gasp alert, which tells me if one of these nodes in the network has disconnected or any issue with the connection. The rest of the system would be the smart DCC, which is the data and communication company, which is the company that collects all of these data and then transfer it to different DCC service users. These would be the energy suppliers, in order to be able to get paid for the energy consumed. Also the network operators, for what we are talking about today, creating benefits from this data or using it for their benefit. Also, I want to show that there are other SEC authorized users. So there are some, if you get the SEC regulated and you get a constraint from any consumer, you can get their energy consumption data as well. So the benefits this program provides, we can see generally for the consumer, it can provide accurate billing, in-home display that can help them closely monitor their consumption and control it, as well as ability to have more flexible tariffs, so they can connect to new tariff programs that can save them money on their energy consumption. And of course, the easier switching between suppliers or changing tariff programs, as I mentioned. But still, in this, although they have all of these benefits, there is a huge social acceptance issue that's preventing this program to achieve its goals. For the electricity suppliers, also, of course, the automated meter reading, saving money on sending some meters to the premises, as well as remote services and less calls handling, and enabling more frequent billing and different programs. So the national benefits would be, it's a huge infrastructure upgrade that to help toward a smarter energy with the digitalization and flexibility aims in mind. Now with the focus, so the DSO technical benefits would start by creating a use of these data. So in our project, we are aiming that since there are these dispersed measurements along the network, we can use these measurements to create from the physical twin another digital twin that can use this digital data, and then we can optimize the operation. And the operation optimization, we can divide it into whole network optimization, so such as active network management, fault mitigation, and outage control. Also asset management, so these data and voltage measurement can improve things such as predictive maintenance or condition assessment of each of the network assets. So this is what I was just talking about, the network planning and the deployment. Also, one of the benefits that Scottish Power are looking for is the detection of low carbon technologies. So the LCT, that now we have more and more electric vehicles or energy storage connected to the lower voltage part of the grid, which is causing some discrepancies in the voltage and frequency. So that digital twin can be used to detect these without sending some dispatch team to these areas. But still, as I mentioned, there are some challenges that are stepping before unlocking all of these benefits, whether on research side or on that industrial side. So one of these challenges are that the constraint of frequency and resolution of the measurements. So we have, as I said, half-hourly measurements. That's not enough for most of the control and protection applications. Also, these data sets, they come like weekly on a basis, or not on a daily basis, or not on a real time. Also, for research purposes, there are some data sets available, such as the UKBN's low carbon London dataset, and there is some other data sets, but still, as I said, these are kind of passive more than an active time data set that we can use for our models. Also, the data protection, that we cannot have the data or smart meter data for each consumer individually. It has to be aggregated for data protection purposes. And as I mentioned, because of social acceptance issues, we are only at 24 million connected smart meters compared to the 53 million target. And this is not enough percentage in order to create a high fidelity digital twin for the network. Finally, as I said, the program comes as an initiative to combat climate change, but it showed a lot of benefits that it can provide to the entire network, and especially to the system operators. And we can say that the acceleration of the rollout that happened since 2021 has motivated a lot of research, and most of the distribution system operators now are having entire teams just to work on the smart meter data and how to make the most of it. But as I said, since there are some challenges constraining this benefit unlocking, we have to address the constraints I mentioned. Thank you.
Do we have any questions? Audience, there's one here.
Yeah, I have a question. I'm already experiencing this from last 6 months.
That's great.
That a smart meter has been put, but it does not communicate. It did not fetch the data, and a couple of times this retailer provider had sent to my house, but I don't know. Even the 53 million we are talking, but what I understood, that is whatever the meter, the supplier has been identified, and this is the supplier who's supplying to all the houses. but it is not communicating correctly. So how will you get the data that it still is a issue?
That's true.
So
That's
have you come across anything? Have you gathered anything from any provider? What is the issue that's happening?
So I know from working with the team, the smart meter team at Scotch Power, that the coverage here in Glasgow area is still at 28%. That's a problem. That's what I said. It's a constraint that we cannot create. Some of the reasons why this is limited. One, the social acceptance. I'm sure some of the people are thinking that having a smart meter that communicates their data might go against data protection. Also, the other reason, as you mentioned, maybe some communication problems with the cellular service at their areas. But these are being handled because I think that might be an issue in more remote areas, but not in the city.
One, was it the last question up here? And then we'll... Sorry, what's wrong with it? It's not the most the best room for running about with arms.
Come as far as I can. Hi, David Greenwood, Newcastle University. So you said that at the moment you don't have enough smart meter data to make this digital twin. What kind of penetration of smart meters would you need in order to be able to do it? Because 100% is probably not realistic. And given the consumer acceptance challenges that already are, how would you persuade someone that you making a digital twin of their behaviour based on their smart meter is something that they want and is kind of ethical and going to persuade them of that, rather than being exactly what they were scared that someone might do?
All right. So the first part of the question, that what is the penetration that I would like to have a digital twin? I think still with the current level, I can still make a digital twin, but it would be limited in its application. So if I can say with the 28%, I can make a digital twin that can be only used for new connections to understand if there has been new connection or not. But I cannot use it, for example, for fault mitigation or fault allocation, because I don't have high fidelity of my digital twin or of my model. The second part of the question, I think it's not our part to convince consumers to connect, but as I mentioned, as long as you provide benefits to them, so as long as you can say, if you have a smart meter, you can be bought on that tariff program that can save you on your electricity consumption at night. So instead of having a fixed tariff or a fixed value of like energy bill, you can save. So once the consumer starts seeing that, they can create the savings. And also one part was the demand side. So one benefit of having the smart meter is the demand side management, that I can have some of the appliances working in correspondence to the utility signal. So I think that also can be something that can convince the consumer to apply for a smart meter or have a smart meter in their house.
Thank you very much.